Good day, everyone, and also to our professor, Mr. Reynaldo C. Rivera Jr. Welcome to Elementary Theory of Numbers. This session is focused on the application of congruence. These are leap year formula and computing the day of the week. I am June Michael B. Caido, the discussant for today. Here is our objectives. At the end of the lesson, you should be able to identify a leap year using leap year formula and solve for the day of the week using Zeller's formula. Let's talk about the leap year. What is a leap year? Leap years are years where an extra day is added to the end of the shortest month, which is February. As we all are aware that the Earth revolves around the Sun, and it takes approximately 365.25 days, which counts to an extra 6 hours. What if we add 6 hours 4 times? We have 24 hours. And also, it is equivalent to 1 day. That's why leap years have 366 days instead of the usual 365 days and occur almost every 4 years. Let's have a leap year formula. Let y be the year. If y is congruent to 0 modulo 4, then y is a leap year, unless y is congruent to 0 modulo 100. In that case, y is not a leap year, unless y is congruent to 0 modulo 400. Then y is a leap year. Let's have our example. Identify the given years if it is a leap year or not. A year 2013. 2013 is not congruent to 0 modulo 4 because when we divide 2013 by 4, we'll get a remainder 1. So that 2013 was not a leap year. Next example, 2008. 2008 is congruent to 0 modulo 4 because when we divide 2008 by 4, we'll get a 0 remainder. And 2008 is not congruent to 0 modulo 100 because when we divide 2008 by 100, we'll get a remainder 8. So that we can say 2008 was a leap year. Let's have another example. A year 1900. 1900 is congruent to 0 modulo 4 because when we divide 1900 by 4, we'll get a 0 remainder. 1900 is congruent to 0 modulo 100 and 1900 is not congruent to 0 modulo 400 because when we divide 1900 by 400, we'll get a remainder 300. So that we can say 1900 was not a leap year. Last example, a year 2000. 2000 is congruent to 0 modulo 4 and 2000 is congruent to 0 modulo 100 and also 2000 is congruent to 0 modulo 400. Therefore, 2000 was a leap year. Now, let's move on to our next topic, which is computing the day of the week. If A is an element of real numbers, then there exists a unique integer m such that A is less than m plus 1 but greater than or equal m. We call m as the floor of x, and is denoted by m is equal to the floor value of a. The formula that gives the day of the week for any date on the Gregorian calendar, known as Zeller's congruence, is given by x is congruent to the floor value of 13m minus 1 all over 5 plus the floor value of y over 4 plus the floor value of c over 4 plus d plus y minus 2c modulo 7, where x is the day of the week. X is 0 means the day is Sunday. X is 1 means the day is Monday. Up to x is equal to 6 means the day is Saturday. Where D is the day of the month. Where M is the month. M is 1 for March, M is 2 for April, M is 3 for May, up to M is 10 for December. M is 11 for January, and M is 12 for February. Where Y is the last two digits of the year if the month is March through December, and last two digits of the year minus 1 if the month is January or February. And C is the first two digits of the year. Now, let's have our example. Verify that November 4, 1987 was a Wednesday. Here is our given values. D is equal to 4 for the day, M is equal to 9 for the month, and Y is equal to 87 for the last two digits of the year, and C is equal to 19 for the first two digits of the year. Here is our formula. X is congruent to the floor value of 13m minus 1 all over 5 plus the floor value of y over 4 plus the floor value of c over 4 plus d plus y minus 2c modulo 7. By substituting the given values to our formula, we'll get x is congruent to the floor value of 13 times 9 minus 1 all over 5 plus the floor value of 87 over 4 plus the floor value of 19 over 4 plus 4 plus 87 minus 2 times 19 modulo 7. And by computing that, we'll get x is congruent to the floor value of 116 over 5 plus the floor value of 87 over 4 plus the floor value of 19 over 4 plus 4 plus 87 minus 38 modulo 7. And now, x is congruent to 23 plus 21 plus 4 plus 4 plus 87 minus 38 modulo 7. Then, x is congruent to 101 modulo 7. Now, x is congruent to 3 modulo 7. Since x is congruent to 3 modulo 7, then November 4, 1987 was a Wednesday. Now, let's have another example. Verify that January 10, 1896 was a Friday. By identifying the given values, we'll get D is equal to 10 for the day, M is equal to 11 for the month, and as you can see, our month is January, then our Y will become 96 minus 1. And C is equal to 18 for the first two digits of the year. Here is our formula. X is congruent to the floor value of 13m minus 1 all over 5 plus the floor value of y over 4 plus the floor value of c over 4 plus d plus y minus 2c modulo 7. Again, by substituting the given values, we'll get x is congruent to the floor value of 13 times 11 minus 1 all over 5 plus the floor value of 95 over 4 plus the floor value of 18 over 4 plus 10 plus 95 minus 2 times 18 modulo 7. By computing that, we'll get x is congruent to the floor value of 142 over 5 plus the floor value of 95 over 4 plus the floor value of 18 over 4 plus 10 plus 95 minus 36 modulo 7. Then x is congruent to 28 plus 23 plus 4 plus 10 plus 95 minus 36 modulo 7. And now, x is congruent to 124 modulo 7. Then x is congruent to 5 modulo 7. Since x is congruent to 5 modulo 7, then January 10, 1896 was a Friday. That's all for today's lesson. I hope you learned and enjoy for our discussion. Thank you and God bless.